అందరికి కాకుండా
equations with the variable coefficients. These equations are divided into two types. First one is the Cauchy-Euler equation. From this, one question is compulsory for JL and also for set. Okay. Now I'm taking a linear differential equation. A linear differential equation. Differential equation of the form an x power n into d power ny by dx power n plus an minus 1 x power n minus 1 d power n minus 1 y by dx power n minus 1 plus and so on a1 x into dy by dx plus a naught into y is equal to q of x. This differential equation is called a linear differential equation of order n, and it is known as Cauchy-Euler equation, where a naught or an, where an minus 1 and so on, a1, a naught are constants is called Cauchy-Euler equation. Cauchy-Euler equation of order n. Now, in order to solve Cauchy-Euler equation, we have to take for solving Cauchy-Euler equation. Let us take x is equal to e power z. It is important. We have to take x is equal to e power z. When x is equal to e power z, then z is equal to log x. X is equal to e power z, then z equal to log x. Here x should be positive number. That means log is defined in the open interval 0 infinity. So we can use some notations here for solving Cauchy-Euler equations. First notation, x into d. D means we know that d by dx, that is equal to theta, where theta is equal to d by dz. Here z is the independent variable, as we know that capital D is equal to d by dx. In d, x is the independent variable. In theta, z is the independent variable. We are changing independent variable x to z. This is important. We are changing the independent variable from x to z. Now, when x into d equal to theta, then x square into d square is equal to theta into theta minus 1. X cube into d cube is equal to theta into theta minus 1 into theta minus 2, and so on. We can write x power n into d power n. X power n into d power n is equal to theta into theta minus 1 into theta minus 2, and so on. Theta minus n minus 1. Okay. Now, after we can substitute in the given equation these values: x equal to e power z, z equal to log x, and xd equal to theta, x square d square equal to theta into theta minus 1, and so on. And substitute all these notations in the given equation. Now we can convert this equation into linear differential equation with constant coefficients. In this case, we can solve the previous methods. After simplification, replace replace z by log x. In place of z, we should write log x. This is the Cauchy-Euler equation. Now, another linear differential equation with variable coefficients is the Legendre equation. The Legendre equation. Legendre's equation. Legendre equation is the extension of Cauchy-Euler equation only. Okay? An equation of the form an equation of the form Kn into, I am writing here, Kn into Ax plus B whole power n d power n by d power n y by dx power n plus Kn minus 1 Ax plus B whole power n minus 1 into d power n minus 1 y by dx power n minus 1 plus and so on k naught into y. Before term is k1 into, I am writing here, k1 into dy by dx, k1 into dy by dx plus k naught into y is equal to q of x. This equation is called the Legendre equation, where kn minus 1 and so on, k1, k naught are constants. Okay. Now this equation is called the Legendre equation. Okay.
The K1 into Ax plus B, sir.
Okay, Ax plus B, it is a function of x. Okay, ఇక్కడ ఓన్లీ నేను kn గురించే మాట్లాడుతున్నాను. Ax plus B is a function of x. ఇందులో x ఉంది అండి. A and B are constants. Okay, is called the Legendre equation. Legendre equation. Now for solving Legendre equation, we can do the same procedure as we discussed in Cauchy-Euler equation. For solving Legendre equation, Legendre's equation, we have to take, or let us take Ax plus B is equal to e to the power of z. In previous Cauchy-Euler equation, we are taking just x. ఇక్కడ మన ప్రీవియస్ కేసులో x పవర్ n ఉందండి, కాబట్టి d పవర్ n y by dx పవర్ n కోఎఫిషియంట్ x పవర్ n ఉంది కాబట్టి x ఈక్వల్ టు e పవర్ z తీసుకున్నాం. ఇక్కడ x పవర్ d పవర్ n y by dx పవర్ n కోఎఫిషియంట్ ax plus b హోల్ పవర్ n ఉంది కాబట్టి ఈ టర్మ్ తీసుకోవాలి, ax plus b is equal to z. Then in this case z is equal to log ax plus b. Okay, by taking anti-logarithm, we get z equal to log ax plus b. Now we can use notations here. Okay, after simplification, we'll get the notations. I am direct writing notations. You have to remember. First, ax plus b into ax plus b into d. In previous case, x into d. That is equal to theta. Here ax plus b is equal into d is equal to a into theta, where theta is equal to d by dz. Z is the independent variable, and we know that capital D is equal to d by dx. And ax plus b whole square into d square, that is equal to a square. This is a square into theta minus 1, and ax plus b whole cube into d cube is equal to a cube into theta minus 1 into theta minus 2. Okay, so and so on. We can continue and so on. We can write the last term ax plus b whole power n d power n is equal to a power. Here for 1 we have 1 here, for 2 2, for 3, 3. So for n, we have n. Theta into theta minus 1, theta minus 2, and so on. Theta minus n minus 1. Okay, last term is one term is here 3, we have 2. Here n, we have n minus 1. Now we can substitute in the given equation these values. Then the Legendre equation becomes linear differential equation with the constant coefficients. Then we can solve by previous methods. After simplification, replace z by log ax plus b. This is the procedure to find the general solution of Legendre equation, and this is the procedure to find the general solution of Cauchy-Euler equation. Okay, compulsory question only for JL and set also. Now I am taking simple problem from DL. Next page. It is from DL. The auxiliary equation of the homogeneous linear differential equation x square into d square plus 3xd plus 1 into y is equal to 1 divided by 1 minus x whole square is. You have to find the auxiliary equation. You can observe clearly it is a Cauchy-Euler equation. ఇక్కడ x power 2 ఉంటే d power 2 ఉండాలి. ఇక్కడ d power 2 ఉన్నప్పుడు x power 2 ఉండాలి. Same ఉండాలి. d power 1 x power 1 same constant. Okay. Now in this case we can observe this is a Cauchy-Euler equation. Let us take x is equal to e power z. Then z is equal to log x, and use the notation x into d is equal to theta, and write the theta value, that is dy dz. We are changing the independent variable from x to z, and x square into d square is equal to theta into theta minus 1. Only we have x square d square terms, so no need to write remaining terms. Therefore, substitute in the equation, we'll get theta into theta minus 1 plus 3 into theta plus 1 into y is equal to 1 divided by 1 minus x. X is equal to e power z whole square as this. Okay. Now, the simplification of this is theta square plus 2 theta plus 1 into y is equal to 1 by 1 minus e power z whole square. Now we have to write the auxiliary equation, that is just replace theta by mu. Theta is equal to m substitute చేయాలి. అక్కడ మనం కాన్స్టెంట్ కోఎఫిషియెంట్స్ లో theta is equal to d equal to m substitute చేస్తాం. ఇక్కడ theta is equal to m substitute చేయాలి. That is m square. One second. This is m square plus 2m plus 1 is equal to 0. This is the auxiliary equation. Okay. Just asking for auxiliary equation only. Okay. Now I am taking another problem from DL. Is from DL. This general solution of the general solution of the homogeneous linear differential equation. Homogeneous linear differential equation. homogeneous linear differential equation. X square into d square minus 4x into d plus 6 into y is equal to x square. Okay. Now, first of all, I am taking, it is a Cauchy-Euler equation. So let us take x is equal to e power z. You have to remember z equal to log x. Okay. And we can write x into d equal to theta and x square d square equal to theta into theta minus 1. Therefore, I am writing directly here theta into theta minus 1 minus 4 theta plus 6 into y is equal to x square, that is e power z whole square, where it mentioned theta value, that is dy dz. So here theta square minus 5 theta plus 6 into y is equal to e power 2z. Now we can, this is a linear differential equation with a constant coefficients. For this equation, we have to take the corresponding auxiliary equation, that is m square minus 5m plus 6 is equal to 0. This can be written as m minus 2 into m minus 3 is equal to 0. That is m is equal to 2 comma 3. These are the roots of the corresponding auxiliary equations. So we can write the complementary function yc is equal to c1 e power x. Here independent variable is z, so we can write c1 e power 2z plus c2 e power 3z. So as we know that e power z equal to x, so we can write yc is equal to c1 e power z whole square, that is x square, plus c2 e power z whole cube, that is x cube. This is the complementary function. Now we have to find the particular integral also. Therefore, yp is equal to 1 divided by theta square minus 5 theta plus 6 of e power 2z. Okay. Now we can use e power ax formula. That is, we should write theta is equal to here 2. Theta is equal to 2. So we can write 1 by 4 minus 10 plus 6. That is denominator is 0. When the denominator is 0, in linear differential equation with constant coefficients, we are taking the numerator x. ఇక్కడ independent variable తీసుకోవాలి, that is independent variable is z. Denominator ను డెరివేటివ్ చేయాలి with respect to theta తో డిఫరెన్షియేట్ చేయాలి, that is 2 theta minus 5 e power 2z. ఓకే, ఇక్కడ ఇండిపెండెంట్ వేరియబుల్ మారిందండి. Previously we are using x, here we are changing x to z. That's why I am writing z and differentiating the denominator with respect to theta. So z as this. Now replace theta is equal to 2. So here 4 minus 5, that is 4 minus 5 e power 2z. That is equal to minus z into e power 2z. That is equal to minus z. Z equal to, we have log x. Z equal to log x and e power z equal to x. This can be written as whole square. So this is equal to minus x square into log x. This is the particular solution. Therefore, the general solution y equal to c1 x square plus c2 x cube minus x square into log x. This is the general solution. Okay.
So denominator differentiation చేసినప్పుడు e power 2z coefficient
e power 2z అనేది ఇక్కడ మనకు ఈ లైన్ కు అవుట్ సైడ్ లో ఉంది కాబట్టి దీంతో మనకు పని లేదండి. ఓకేనా, ఓన్లీ డినామినేటర్, ఈ టర్మ్ ఇంకా ఇటువైపు రాలేదు. ఎప్పుడు ఇటువైపు వస్తుంది అంటే దీని అంటే ఇది వర్క్ ఈ పవర్ డి థీటా ఈక్వల్ టు 2 సబ్స్టిట్యూట్ చేసినప్పుడు ఈ వాల్యూ రాసుకుంటుంది. ఇప్పటివరకు ఇది ఇక్కడే ఉంటుంది. ఓకేనా
సార్, డినామినేటర్ ని డిఫరెన్షియేట్ చేసినప్పుడు e పవర్ 2z చేంజ్ అవ్వదా సార్?
చేంజ్ కాదండి, అది దాంతో మనం దాన్ని అలానే ఉంచాలి. జస్ట్ డినామినేటర్ నే డెరివేటివ్ చేయాలి.
ఓకే ఓకే.
Now I'm taking another problem. From recent Gurukul jail. Is jail Gurukul. The general solution of the general solution of x square d square y by d x square minus x into dy by dx plus y is equal to 0 is y equal to. Okay, we have different options here. First I am writing in the operator form. This is x square d square minus xd plus 1 into y is equal to 0. Now we know that it is a Cauchy-Euler equation. Let us take x is equal to e power z, then z equal to log x. You have to remember this points. So x into d equal to theta, x square d square equal to theta into theta minus 1. Theta into theta minus 1 minus theta plus 1 into y is equal to 0. Now mention theta value. Theta means this is the differentiation with respect to z. Now I am taking simplifying this, we get theta square minus 2 theta plus 1 into y is equal to 0. Now taking the corresponding auxiliary equation. The auxiliary equation is m square minus 2m plus 1 is equal to 0. That is nothing but m minus 1 whole square equal to 0. M is repeated root. When it is repeated root, then we write yc as c1 plus c2. అక్కడైతే మనం x అని రాసుకునే వాళ్ళం, ఇండిపెండెంట్ వేరియబుల్ x కాబట్టి ఇక్కడ ఇండిపెండెంట్ వేరియబుల్ z కాబట్టి c1 plus c2 z into e power z. This is nothing but c1 e power z plus c2 z into e power z. Now this is equal to c1 e power z equal to x plus c2 e power z. First I am writing this value x z equal to log x. This is the complementary function. Now it is homogeneous equation, so we can write the complementary function is the general solution. Therefore y, this is the y, general solution of the given differential equation. Okay, now I am taking another question from DL. The particular integral of the differential equation d square y by dx square plus 1 by x into dy by dx is equal to 12 log x by x square. 12 log x by x square is. So it is not in the form of x square d square plus x into dy by dx. So we can multiply with x square. So it is converted into x square d square y by dx square plus x into dy by dx is equal to 12 log x. 12 log x. So the operator form is x square d square plus x into d into y is equal to 12 log x. Clearly it is Cauchy-Euler equation. Let us take x is equal to e power z, okay, z equal to log x, and substitute here x square d square value is theta into theta minus 1, okay, plus x into d is theta, y is equal to 12 into log x. Log x is equal to z. You can write z. Here theta square, okay, minus theta plus theta will be cancelled. That is equal to 12 z. Now we need to find just a particular integral. So the particular integral yp is equal to 1 divided by theta square of 12z. As we know that where theta is equal to d by dz. Theta means differentiation with respect to z. So 1 by theta is integration with respect to z. So theta square means 1 by theta square means 2 times integration. 1 by theta 12 into z integration z square by 2. Okay. And again integrate to get 6 into z cube by 3. Okay. This is 6. This is sorry. Okay. 1 second. Okay, this is 6 3 2s are, that is equal to 2z cube. This is 2z cube. Now, as we know that z equal to log x, that is equal to 2 into log x whole cube. This is the particular integral of the given differential equation. Okay. Now I am taking another problem from JL. It is also from DL. Okay. A solution of the ODE. A solution of the ordinary differential equation d square y by dx square plus 2 by x into dy by dx is equal to 0 is y equal to. Okay. Now it is not in the form of x square d square y by dx square plus x into dy by dx equal to 0. So first we have to multiply the entire equation with multiplying with x square. Then we get x square into d square y by dx square plus 2x into dy by dx is equal to 0. So here x square into d square plus 2x into d into y is equal to 0. Clearly, it is Cauchy-Euler equation. Then we have to take x equal to e power z. When x is equal to e power z, then z is equal to log x. And the substitute here, this is x square d square is theta into theta minus 1 plus 2 into x into d is theta into y is equal to 0, where theta is the differentiation with respect to z. So here we have theta square plus theta into y is equal to 0. So we have to take the corresponding auxiliary equation. Auxiliary equation m square plus m is equal to 0. M as common, m plus 1 is equal to 0. That is m is equal to 0 comma minus 1. When m equal to 0 comma minus 1, then we can write the complementary function. That complementary function is the general solution because it is a homogeneous linear differential equation with variable coefficients. So C1 e power 0z plus C2 e power minus z. Okay, e power 0z is nothing but C1 into, I am writing simply it is C1. Now this is equal to C1 plus C2 by e power z. Now this is equal to C1 plus C2 by x. E power z is equal to x is the general solution. Okay. Now I am taking another problem. From jail. The solution of x square into y double dash minus x into y dash plus y is equal to log x. Satisfying that y of 1 is equal to y dash of 1 is equal to 0 is. And given boundary condition y of 1 and y dash of 1 equal to 0. First, you can write the given equation in operator form x square d square minus x into d plus 1 into y is equal to log x. Clearly, it is Cauchy-Euler equation. Let us take x is equal to e power z, then z is equal to log x. And substitute here in this, we get x square d square value theta into theta minus 1, x into d value theta. This is 1 into y is equal to log x. Log x is equal to z. So here it is theta square minus 2 theta plus 1 into y is equal to 0. The corresponding auxiliary equation m square minus 2m plus 1 is equal to 0. This is nothing but m minus 1 whole square equal to 0. M equal to 1 comma 1 are the repeated roots. When they are repeated roots, the complementary function phi c equal to c1 plus c2 z into e to the power of z. Now this is nothing but c1 e power z plus c2 e power z into z. So we can write this as c1 e power z is x, c2 e power z is x, z equal to, we can write it as log x. This is the complementary function. Now we need to find particular integral also. Okay, it is equal to log x, non-homogeneous equation. So I am writing yp is equal to 1 divided by theta square minus 2 theta plus 1. Here log x means z. This is the z line. So it is in the form of 1 by 1 minus theta whole square or theta minus 1 whole square. Both are same. So into z. Now this is equal to, we can take this term into numerator, 1 minus theta whole power minus 2 of z. Now expand 1 minus theta whole power minus 2 by binomial theorem, 1 plus 2 theta. Okay, 2 theta is enough. No need to take 3 theta square because it is of first degree into z. So this is equal to multiply with z plus 2 into differentiation of z is. So z equal to log x plus 2 into 1 is 2. This is yp. Now we can write the general solution. Therefore, y is equal to yc plus yp. That is c1 x plus c2 x into log x plus this is log x plus 2 particular integral. This is nothing but y of x. So differentiate this y dash, that is equal to c1 plus c2 x into log x UV method, x into 1 by x plus log x into 1 plus log x differentiation 1 by x constant differentiation 0. So this is y dash is equal to c1 plus c2 of 1 plus log x plus 1 by x. This is the sum I am taking equation 1 and this is equation 2. Now apply the boundary condition. First boundary condition, y of 1 is equal to what we are given, y of 1 equal to 1. No, y of 1 equal to 0, y dash of 1 equal to 0. So I am taking the first boundary condition, y of 1 equal to 0. Then substitute in equation number 1. So c1 x equal to 1 here, y equal to 0. So 0 is equal to c1 plus c2, x is 1, log 1 is 0. So this term is 0, plus log 1 is 0, this term is 0, plus arbitrary constant is 2. Sorry, constant is 2. So from this we can write c1 is equal to minus 2. And apply the second boundary condition. Y dash of 1 is equal to, y dash of 1 is equal to what we have? 0. It is also 0. So substitute here in this, Already we know that C1 is equal to -2. You substitute చేసుకోవచ్చు. -2 plus C2 of 1 plus log 1. Log 1 is 0. Log 1 is 0. Plus 1. It is 1 by x. 1 by x. Yes, x. Is x. So it is 1. Is equal to 0. Is equal to 0 means here C2 is equal to 1. C2 is equal to 1. -2 plus 1 is -1, goes to outside, we get 1. Therefore, the general solution is y of x is equal to, substitute in equation number 1. Equation number 1 is C1x, that is -2x plus C2 x log x, that is 1x log x. X log x plus log x as this plus 2 arbitrary constant. This is the general solution of the given differential equation. It is JL and also from PL. Polytechnic lecturers lo kuda adigaru, but options lo koncham difference icharu. Okay, now I am taking another problem from JL. It is also from JL. Putting x is equal to e power z and theta is equal to d by dz. Theta is equal to d by dz in x square d square minus x into d plus 2 into y is equal to x log x. X log x. The transformed equation. The transformed equation is. As we already are given x equal to e power z, theta is equal to d by dz. When x is equal to e power z, if x is equal to e power z, then we can write z is equal to log x. And theta, x into d equal to theta, x square d square equal to theta into theta minus 1. And in substitute in this, you get theta into theta minus 1 minus theta plus 2 into y is equal to x. X means e power z and log x means z. So it is nothing but theta square minus 2 theta plus 2 into y is equal to z into e power z. This is the transformed equation of the given differential equation. Okay, I am taking another problem from GATE 2021. Okay, I'm not mentioning there. Let y of x be the solution. Of the following initial value problem. X square into d square y by dx square minus 4x into dy by dx plus 6y is equal to 0. Once again, x square d square y by dx square minus 4x dy by dx plus 6y is equal to 0. X is greater than 0. Y of 2 is equal to 0. And dy by dx of 2 is equal to 4. Then y of 4 is equal to dash. Okay, the options leave just we have to find the y of 4 value. Okay. Now clearly it is Cauchy-Euler equation. X square d square terms are writing operator form. First of all, x square d square minus 4xd plus 6 into y is equal to 0. It is homogeneous. So let us take x equal to e power z. Then z is equal to log x. And substitute x into d equal to theta, x square into d square equal to theta into theta minus 1. That is theta into theta minus 1 minus 4 into theta plus 6 into y is equal to 0. So we can write this as theta square minus 5 theta plus 6 into y is equal to 0. So we can take the corresponding auxiliary equation. Okay? The corresponding auxiliary equation is m square minus 2m plus 6 is equal to 0. Nothing but m minus 2, m minus 3 is equal to 0.
M square minus 5m, sir.
5m, sir. Minus 5m.
Yeah, I'm sorry. Yes, that's why minus 5. Okay. M equal to 2 comma 3 are the distinct real roots. So we can write the complementary function become the general solution. So I'm writing directly y equal to c1 e power 2z plus c2 e power 3z. So this is nothing but c1 e power z whole square, that is x square, plus c2 e power z whole cube, that is x cube. This is the y of y of x value. I am taking equation number 1 and differentiating with respect to x. So we get to 2c1 x plus 3c2 x square. I am taking this as equation number 2. Now apply the boundary conditions, initial value conditions. First, I am applying the first boundary condition and y of 2 equal to 0, y dash of 2 equal to. Okay. Now I am taking first boundary condition, y of 2 is equal to 0. Y of 2 equal to 0 means 0 is equal to x equal to 2 only. So 4c1 plus 8c2. So this is nothing but 4c1 plus 8c2 equal to 0. Just I am writing. No need to write this. This is equation number 3. And apply the second boundary condition d by dx of y of 2.
Sir, 12c2 అనుకుంటా సార్.
Yeah.
12c2.
కాదండి, నేను ఇందులో సబ్స్టిట్యూట్ చేశానండి ఈక్వేషన్ 1 లో
8c2నే.
8c2 నే కదా, x ఈక్వల్ టు 2 అంటే ఇందులో x స్క్వేర్ అంటే 2 స్క్వేర్ x ఈక్వల్ టు 2. 1 లో సబ్స్టిట్యూట్ చేశానండి ఫస్ట్. ఓకేనా? Then apply in this condition. Second boundary condition is dy by dx of 2 equal to 4. dy by dx of 2 is equal to 4. That means 4 is equal to, apply now in equation number 2. That is 4c1 plus 4 into 3, 12c2. Okay, this is the equation number 4. Now solve these two equations. This is minus and the minus. 4c1 will be cancelled. Now minus 4 is equal to minus 4c2. c2 is equal to 1. After getting c2 value, we can write the c1 from equation 1. That is 4c1 plus 8 equal to 0. From this c2 is equal to minus 2. Now c2 is equal to minus 2 and I'm sorry, it is c1. c1 is equal to minus 2, c2 equal to 1. Can substitute in equation number, so we get a y of x, and y of x is equal to c1 value. This minus 2 x square plus c2 value 1 x cube. Now apply x equal to 4. We need to find y of 4. That is y of 4 is equal to minus 2 into 16 plus this is 64. 64 minus 32. It is equal to 32. 32 is the required answer of the given differential equation. Okay. Now I am taking another problem from gate let y of x be the solution of the initial value problem. X square y double dash plus xy dash plus y is equal to x with the initial conditions y of 1 equal to y dash of 1 is equal to 1. Stop. Then the value of y power y of e to the power of 5 by 2 is. Okay. Now clearly it is a Cauchy-Euler equation. So let us take x equal to e power z and z is log x. And I am writing the operators notations here. That is theta into theta minus 1 plus theta plus 1 into y is equal to x means e power z, where theta is d by dz. Now here theta square plus 1 into y is equal to e power z. So take the corresponding auxiliary equation. M square plus 1 is equal to 0. That is m is equal to plus or minus I. Therefore, the complementary function C1 cos z plus C2 sin z. Actually, the C1 cos x plus C2 sin x and independent variable z kabatti C1 cos z plus C2 sin z and rasa. Therefore, YC is equal to C1 cos z equal to log x plus C2 sin z equal to log x. This is the complementary function. Now we go for particular integral. Now yp is equal to 1 divided by theta square plus 1 e power z. Now replace theta is equal to 1 here. So this is equal to 1 by 2 e power z. 1 by 2 e power z means 1 by 2 e power z is x. This is particular integral. Now therefore the general solution y is equal to C1 cos log x plus C2 sin log x plus 1 by 2x, nothing but x by 2. Okay, this is the equation number 1. Now differentiate this with respect to x once. That is y dash is equal to cos differentiation minus sign. So minus C1 sin log x. Again differentiate log x, will get to 1 by x plus C2 sin differentiation cos log x. Again differentiation log x, will get to x plus x by 2 differentiation is 1 by 2. Okay. Now this is the condition equation number 2. Now apply the boundary conditions. Y of 1 equal to y dash of 1 equal to first 1 by 1 I am applying. Y of 1 is equal to 1. When y of 1 equal to 1 means here this is 1. C1 cos log 1 is 0 plus C2 sin log 1 is 0 plus 1 by 2 is equal to here y. So C1 into cos 0 is 1, C2 into sin 0 is 0. So we get to C1 only. Here 1 minus 1 by 2 become 1 by 2. C1 value is 1 by 2. Now apply the second boundary condition. Second boundary condition, y dash of 1 is equal to 1. When y dash of 1 is equal to 1, then I am writing here minus C1 value is 1 by 2, I am writing Sine log 1 is 0, denominator is 1, plus C2 cos log 1 is 0, denominator is 1, plus here we have 1 by 2, yes, 1 by 2 is equal to 1. So this is 0, completely 0. This is C2, this is 1 minus 1 by 2. Now nothing but C2 is also 1 by 2. We have C1 and C2 values, both are equal to 1 by 2. Now substitute C1 and C2 values in equation number 1. Then we get y is equal to, therefore y is equal to C1 1 by 2, C2 1 by 2, కాబట్టి 1 by 2 బయట పడేస్తున్నాం. ఏమొస్తుంది cos log x plus sin log x ఇక్కడ మనకు టర్మ్ కూడా పర్టికులర్ ఇంటిగ్రల్ x by 2 ఉంది, x by 2 నుండి నేను 1 by 2 బయట పడేస్తాను కాబట్టి x ఉంటుంది. Okay, this is the y of x value. So therefore y of e to the power of pi by 2 value, just replace x by pi by 2 here in this. 1 by 2 cos log e to the power of pi by 2 to the base e, and base you mentioned e. Sin log e to the power of pi by 2 to the base e, plus this is pi by 2 as this. So this is equal to 1 by 2 of log e to the power of pi by 2 to the base e is nothing but pi by 2, cos pi by 2, cos pi by 2 this is, and this is sin pi by 2. This is pi by 2 as this.
Sir, e power pi by 2, sir.
అదేనమ్మా ఇక్కడ మనకి ఫార్ములా ఏంటంటే e పవర్ log x to the base e is equal to x అన్నమాట, ఇది ఫార్ములా. ఓకే,
లాస్ట్ టర్మ్ x ప్లస్ లో e పవర్ pi by 2 రాయాలి.
okay, I'm sorry, here it is e power pi by 2.
Pi by 2.
So this is 1 by 2, this is cos pi by 2 0, this is 1 plus e power pi by 2. So this is equal to 1 by 2 plus 1 by 2 e power pi by 2. This is the general solution, y of e power pi by 2 value. Okay, this is. Now I am taking another problem from APJL. 1 second. Yes. A recent APJL. I'm just writing here on APJL. The solution of 1 plus x whole square d square y by dx square plus 1 plus x into dy by dx plus y is equal to 2 times of sin log 1 plus x each. This is the question. We have to find the general solution. Okay, it is not in the form of x square d square y by dx square plus x into dy by dx. It is in the form of ax plus b. Actually the name is calling x plus 1 whole square into d square, x plus 1 into d plus 1 into y is equal to 2 into sin log 1 plus x plus 1. So here in this case we have to take x plus ax plus b is equal to e power z. That is, we have to take x plus 1 is equal to e power z. Then z is equal to log x plus 1. And substitute the values. We know that I am writing the values here. x plus 1 into notations d is here x coefficient రాసుకోవాలి. అక్కడ ఏం రాసాం a into theta. Next to a square into theta minus 1. A equal to 1 కాబట్టి 1 into theta అని రాసుకోవాలి. Nothing but theta. Next x plus 1 whole square into d square is equal to 1 square into theta minus 1. Nothing but theta into theta minus 1, where you have to mention theta value. dy dx. Okay. For convenient నేను రాస్తున్నాను, లేదు డైరెక్ట్ ఇందులో సబ్స్టిట్యూట్ చేసుకోవచ్చు. యొక్క వాల్యూ రాసేసి డైరెక్ట్ ఇందులో సబ్స్టిట్యూట్ చేసుకోవచ్చు. కన్ఫ్యూజ్ లేకుండా ఉండడానికి కోసం రాస్తున్నాను. Therefore, this is theta into theta minus 1 plus theta plus 1 into y is equal to 2 sin log of x plus 1 is z. Okay. So here theta square plus 1 into y is equal to 2 sin z. Now take the corresponding auxiliary equation. Just take the corresponding auxiliary equation. That is m square plus 1 equal to 0. M is equal to plus or minus I. So the complementary function yc is c1 cos z plus c2 sin z. That is equal to c1 cos z. Z means log of x plus 1 plus c2 sin. Z means log of x plus 1. Okay, this is the complementary function. Now we go for particular integral. Yp is equal to 1 upon theta square plus 1 of 2 sin z. 2 sin z. Just we know that theta square equal to minus 1. That is minus a square. Minus a square means it is minus 1. When we substitute minus 1, the denominator will be 0 here. So take z in the numerator. Z means independent variable z, and differentiate the denominator. So 2 into sin z. ఇక్కడ డిఫరెన్షియేట్ చేసినప్పుడు sin z తోటి మనకి ఏం పని లేదండి, ఇంకా యూజ్ చేసుకోవట్లేదు. జస్ట్ 2 క్యాన్సిల్ చేయాలి. z into 1 by theta means integration of sin z with respect to z, that is minus cos z. So this is equal to minus z. Z means log x plus 1 into cos again z, that is log x plus 1. This is the general solution of the given. This is the particular integral. So we can write the general solution is the sum of complementary function. Therefore, the general solution y is equal to yc plus y. You can write the yc and the yp values. Now I am taking another problem from Polytechnic, and also it is from civil service. Okay. The general solution of 1 plus 2x whole square into d square plus minus 6 into 1 plus 2x into d plus 16 into y is equal to 8 1 plus 2x whole square. 1 plus 2x whole square is. Okay. This is the given differential equation. Clearly it is a Legendre equation. So we can take a direct, I am taking 1 plus 2x is equal to e power z, then z is equal to log 1 plus 2x. So we can write the, I am writing individual values here. 1 plus 2x into d is equal to x coefficient here 2. So we can write 2 a into theta, 2 into theta, where theta value is d by such. And 1 plus 2x whole square into d square, that is equal to 2 square into theta minus 1. Okay, that is nothing but 4 theta into theta minus 1. And substitute in the given equation in this. So we get 4 theta into theta minus 1 minus 6 into 2 theta plus 16 into y is equal to 8 into 1 plus 2x. 1 plus 2x is equal to e power z whole square means e power z whole square. Okay. Now here first term 4 theta square and minus 4 theta minus 12 theta minus 16 theta plus 16 into y is equal to 8 into e power 2z. You can cancel with 4. So theta square minus 4 theta plus 4 into y is equal to 2 e power 2z. So we can take the corresponding auxiliary equation. That is m square minus 4m plus 4 is equal to 0. We can write this as m minus 2 whole square, m minus b whole square. M is repeated root of 2, repeated roots. So the complementary function yc is equal to I'm writing here c1 plus c2z into e power 2z. Okay, now this is equal to c1 e power 2z plus c2 e power 2z into z. This is equal to c1 e power z is x, e power 2z is x square plus c2 into x square into z. Z is equal to log 1 plus 2x. We are taking z equal to log 1 plus 2x. This is the complementary function. Now we have to find a particular integral also. So yp is equal to 1 upon theta square.
Sir, ఇక్కడ e power 2z అంటే 2x plus 1 whole square.
1 plus 2x.
I'm
E
sorry.
power 2z, sir.
But 1 plus 2x whole square.
Next term ఉంటుంది, sir.
C1 1 plus 2x whole square plus C2 1 plus 2x whole square. This is the complementary function. Now we go for particular integral, that is 1 by theta square minus 4 theta plus 4 of what we have 2 e power 2z. 2 e power 2z. Already 2 is a factor, one time factor kabatti denominator automatically 0 avutundandi. So we can write z in the numerator and differentiate the denominator with respect to this. We get minus, and this is minus 4. So 2 e power 2z. Again, denominator again is 0. So we can write z again in the numerator. That is z square by 2. 2 e power 2z. 2 will be cancelled. So when 2 will be cancelled, this is the particular e power 2z. E power 2z means 1 plus 2x whole square. Z square means z equal to log 1 plus 2x. So 1 log 1 plus 2x whole square. Okay. This is the particular integral. Now we have to find the general solution. Therefore, the general solution is y equal to yc plus y. Now I am taking one set problem. Recent set problem. Particular simply particular integral of the differential equation x square d square y by d x square minus x dy by dx plus 2y is equal to x log x is. Same, it is clearly very important, interesting problem. Ikkada particular integral kuda x log x vastundi. Okay. Now, first we are taking x is equal to e power z and z equal to log x. And substitute here, this is theta into theta minus 1 minus theta plus 2 into y is equal to x e power z log x is z. So, the theta square minus 2 theta plus 2 into y is equal to z into e power z. No need to find a complementary function. Just we have to find the particular integral only. So yp is equal to 1 divided by theta square minus 2 theta plus 2 z into e power z. Okay. So first it is in the form of e power ax into b. When it is in the form of e power ax into b, we should replace d by d plus a. Here a is equal to 1. So replace, here it is theta by theta plus a. Okay. Theta plus a means theta plus a equal to 1. When we are writing theta is equal to theta plus 1, e power z goes to this side. That means e power z divided by theta plus 1 whole square minus 2 into theta plus 1 plus 2 into z. E power z panayipindi. Now we have to simplify for z only. So here e power z divided by theta square plus 2 theta plus 1 minus 2 theta minus 2 plus 2. Okay, you can direct kuda cancel chesukochu meeru. 2 theta and 2 will be cancelled. So this is equal to e power z by 1 plus theta square. I'm getting like this z. And take to numerator e power z into 1 plus theta square whole power minus 1 z. And expanding e power z into 1 minus theta square into z. Now this is equal to e power z into multiply with z. Theta square means 2 times differentiation. 1 time differentiation is 1, again differentiation is 0. So this is nothing but e power z. E power z is x, z is log x. So this is the particular integral. Okay. These are the some problems. We will discuss some more problems in next class.